All right, I'm going to continue the notes with part 2. We just did this in the last lecture. I'm not going to do all this for those, we already did it. But if you want to fill this in, remember domain is all reals and range is all reals. So you can fill that in. What I need to teach you now is cube root functions. Check out the cube root functions, y'all. You can basically see this right here. It is almost exactly like the cube or the x cubed function, but it's twisted. Can you tell how it's twisted? If you can't, let me show you something that's kind of neat. I'm going to show it to you on my computer screen. Why is this not opening? Yeah, there it is. Let me show you what that looks like. So I'm going to take this picture, and then I'm going to flip it. Somehow I'm going to flip it. I forgot how. Oh, I'm going to take it here, and I'm going to take it into Paint. 1 second. I know this is silly, but I want you all to see it. I'm going to take it into Paint. Now watch this. I can rotate this by 90 degrees, and boom. You have the exact same shape we're dealing with. So you're dealing with more or less the same numbers, they're just inverted. Remember that term inverted? Inverse is x and y being switched. So this is pretty straightforward. I'm going to do these points together. So I'm going to put in for my x values, I'm going to have a -8 for my x value. I'm going to have a -1 for my x value. I'll have a 0, and then I'll have a 1, and then I'll have an 8. Notice these are just flipped around. So my -8, when I plug in my -8, I will output a -2 for my y. When I plug in a -1, I'll output a -1. When I put in a 0, I'll output a 0. When I plug in a 1 into this, and you can see it up here, I'm plugging into this equation right here. When I plug in a 1, I get a 1. When I plug in an 8, I'll get a 2. And why? Because the cube root of 8 is 2. So the domain is also all reals. This is also all reals, so make sure you have this filled in like that. The range is also all reals. It's not that big of a deal, and this is the parent function right here. This is what you need to have, and I'm going to have to add this to my list of charts to make. So with that said, I'm going to go ahead and click to the next stuff. This is why I didn't want to do these notes very much. It is the same transformation. When it's next to the x, your x is going to lie. So this is going to go right 3, this is going to go left 1, this moves up 6, this moves down 4. Y'all notice how this is the same stuff over and over? I don't feel I need to repeat it. You just need to know the shape. Remember what the shape is. So check out this one. This thing moved down 2. This thing moved down 2. So what is my answer? It's outside. And then I'm going to write the little all reals. I don't know how to write that R. Ooh, that's not it. It's like some weird R you can write that looks like this. It's like all reals. I'm just doing that to save time and to expose y'all to it. That's not exactly the shape of it, but you can also do the -infinity to infinity. So all I did was look at the transformation, and you're following this point. If you can't tell, see this point here, up there, and then you're following it whenever it makes a transformation. So let's look at this next one together. This one is moving left and right. That means it is inside the house, more or less. And since it went left, I know that that's lying to me, and it went that way 3 times. Did it go up or down? It did not. The domain is the same. The domain is the same. The range is the same. Cool. Not a big deal. Going to the next stuff. Same here, y'all. I'm going to show you this. This flips as well. 1 second. All right, y'all. Here's the thing as well, too. You see this negative here? It also reflects the same way. You can see at the top, they tell you in the notes what it does. The negative outside flips it over the x-axis. The negative inside flips it over the y-axis. But because it has that rotational symmetry, it's more or less the same thing. So I'm going to graph the original one in black. So it's kind of hard to do, but all you need to do is worry about these 3 points, this one, and this one. And you kind of just like do your best creating the shape. Do your best creating the shape. You can see mine's not that great. I'm going to draw the original one over here as well, too. Do your best creating the original shape. Do your best creating the original shape. Now, when you plug in these answers, here's what happens when you switch on the first one. This is going to flip over, and it's going to look like this. So your points are going to be like this. Again, sorry for my drawings. They're not that great. See how it's the same? And this one here will also have the same thing. The points flip, and you end up with like that little weird shape, more or less. And that's not perfect, but just make your point look bigger. And that's it. They're basically the same thing over and over. So I'm going to push pause and fill in the number chart. So there you have it. With that said, that's how you solve these. I put the numbers in, And you can clock that the numbers are the exact same for these graphs. So when you see a negative somewhere like that, just know that on these two, on the cube root and on the cube itself, like the cubic x to the third, the reflections are the same. So that's kind of a thing to know. Easy to forget. I don't know how many of these problems they're going to be asking us to do. I hate this notation. I hate this notation. So yeah, I hate this notation. I'm not teaching it. I'm just removing that. If it shows up on the Delta Math, skip that problem. I'm going to remove it from there anyways. I guess that's it. That's really all I care about for this material.